Okay. This is an X-ray gun which produces an X-ray like this. And this is X-ray receiver. Now, thing is that this X-ray gun can rotate around the patient. This X-ray gun can rotate. Similarly, this X-ray receiver can rotate as well.
Assalamualaikum, sir.
Walaikum assalam. And this X-ray receiver is always in front of X-ray gun. So it can take a scan at 0, then it can take a scan at 45 degree, then it can take a scan at 90 degree, then it can take scan at 135 degrees. Okay. So this way it can have multiple scans, one after the other. No. Any part of the body that we want to scan. Well, first of all, what computer does is computer converts that part into small slices. Computer converts that part into small slices. Now, each slice is then converted into small voxels. And the value of every single voxel is measured by multiple scans. Each voxel either fat, muscle, bone, tissue, etc. This can be distinguished on the basis of X-ray absorption. Different materials absorb different amount of X-ray radiation. Different materials, for example, fat has different absorption of X-rays than bone. Muscles have different the absorption than fat. Fat has different than tissues. Tissues have different than blood. Blood has different than vessels. Vessels have different than skin. Skin has different than any other things that can be there. Okay. So everything has its own different kinds of absorption. So if computer can find out the nature of every single voxel in a slice, by connecting all those voxels together, computer can generate image of a slice. And by making images of side by side different slides, computer can see a three-dimensional image of the part. This is called CT scan. Now, if you want to see how CT scan machine looks like, Look. This is a kind of machine where X-rays and receivers can move. Okay, in this case, I hope you can see the X-ray can move inside this machine like this, and receiver can move like this. But receiver is always in front of X-ray. So when X-rays are produced like this, and there is patient in between, we make the patient lay on this stretcher, and then we roll the person into the machine. So I hope you can see that circular part over there. This is where the, just 1 second, let me use it brighter color. This is where the X-ray machine is moving, and opposite to that is where the receiver is moving. So in this case, multiple images can be generated by at different angles for the same patient, and by overlapping them with one another, we can generate a 3-dimensional image. This is the kind of image we should be expecting to see when we do CT scan. So this is how doctor can see different slices. Okay. This is the same patient, and this is showing different parts of the plane. So this is slice 1, slice 2, slice 3, slice 4, 5, 6. So this is how different slices are generated from the computer. Okay. And now doctor can understand length, width, height, and depth of the tumor. For example, doctor sees a tumor here. Okay. Do you see this blue spot? This is where the tumor is. Now doctor can see how tall is this. Doctor can see how wide is this. Now doctor can see that there was some portion of this tumor shown here, and there was some tumors portion shown here, and some was shown here. Okay. So you can clearly see that it is shown in 1, 2, 3, 4 diagram. And if you know the size of the slice, you can find out that this object is somewhere over here, and it is 1, 2, 3, 4 layers deep. So doctor can actually pinpoint the exact position. So CT scan provides multiple information of any piece of body. It takes images in multiple directions, and all the images are overlapped on one another. And 3D images produced. Now, I have some past paper questions over here. In past papers, question is always about CT scan. Hmm. Here is a question. 6-mark question. Outline the principle of computed tomography. The part of body under study is the part of body under study is divided into thin slices. Each slice is further split into small equal. Each slice is further split into small equal sections. Each section is called voxel. In CT scan, X-ray emitter and receiver can rotate in CT scan. X-ray emitter and receiver can rotate around the part of body. CT scan X-ray either X-ray emitter and receiver can rotate around the part of body under investigation. Multiple absorptions In CT scan, X-ray, eye emitter and receiver rotate around the part of body under investigation. Multiple absorptions are made when X-ray and receiver multiple absorptions are made from X-rays and receiver when moved. Okay, so when we will be firing gamma radiations from different X-ray radiations from different directions, there will be different kind of absorption for the material. So X-ray will be absorbing multiple absorptions are made from X-ray and receiver as shown in the figure. Moved. Voxel value of each piece of thermopole. Voxel value of each piece of thermopole multiple absorptions are made when X-ray and receivers are moved. Mm. Voxel value of each piece in slice is determined using using matrices. Matrices is a way that we use in math to find out unknowns, also known as matrix. So in CT scan, you should know. Okay. This is all that you need to know. Can you go to the same page?
Yes, sir.
Okay. I would like you to read it by yourself. I have shared the same document in PDF form. Can you open this page and read it for yourself? Go to this page on your PDF, read this whole page.
So what are the different types of questions that we're gonna get in this?
In CT scan, mostly the question will be that explain the principle of CT scan. A student should be able to understand that X-ray and X-ray detector, they can move 360 degrees around the patient. Multiple X-rays are sent and received. And when X-rays are sent and received in multiple directions, com- uh,
Computer makes it a single slice and
computer splits the whole part of the body into simple slices, thin slices. Then every thin slice is further divided into voxels. Computer
yes.
measures absorption coefficient of each voxel, on the basis of which computer can find out the exact pinpoint position of any certain particle. Done reading?
Yes, sir.
Yes, sir.
Good. Any confusion?
So do we have to give that each and every detail like this, talking about the pixels and everything?
That is a second kind of question. That is very rare, but it is seen in past papers.
Like while describing the voxels, like we don't have to give the specific examples like pixels and everything.
Why not? Pixel, listen, pixel and voxel, how are these two things different? Pixel is a small piece of a two-dimensional screen. Okay, my camera is 15 million pixels, or my tablet screen is 2000 megapixels. My camera is so many megapixels. Have you ever heard of these phrases?
Yes, sir.
So pixel is normally used as a small unit, small equal size unit on two-dimensional thing. Their three-dimensional brother is called voxel. So voxel is a three-dimensional pixel. Okay. Now, how to find out values of voxels? Now, we will pass multiple X-rays, like we will pass X-rays like this. We will record the results. Then we will pass X-rays like this, and we will pass record the result. Then we pass X-rays like this, and we record the result. And then we will pass X-rays like this, and we will record the result. Okay. X-ray, they move around the material, actually the patient. Okay, what will the sum of these two on the top? What is sum of 4 and 1? 7 and 2. Okay. What is the total of this? Okay. The sum of all numbers is sure. So background radiation will be so background radiation will be sum of all numbers. Which will be 14. So either you can add the two numbers in the resultant or you can add all the four numbers together. In both cases, you should get the same answer as 14. Okay. Now X-rays are repeated. In multiple directions and multiple uh, scans are done. Okay, one after the other, and values are overlapped on top of the or on the top of the each other. Okay, so we finally have this number. This is where you should know. This is after all scans. Now, number one, subtract background radiation subtract background radiation. Number two, divide subtract background radiation divide each number by 3. So what was the background radiation? Subtract that number from each number. Background radiation was 14. So subtract 14 from each number. What will be the result? Hello? Can you subtract 14 from each number?
Yes, sir.
Okay, after you're done with that, can you divide every number by 3?
Top left is 4. Top right is 1.
Mhm.
Bottom left is 2.
Mhm.
Then bottom right is 7.
Oh, that is exactly equal to what we started with. Okay, we started with 4, 1, 2, 7, but we did not know these values. We didn't know. Okay, we didn't know these values, but we got the first scan as 5, 9, second scan as 1, 11, 2. We overlapped this one with the previous one. We kept doing it till the last scan, and this is what we got. So first of all, we subtract the background radiation and then we divide the whole thing with 4, no 3. Okay, here's a question. Okay, state the principle of CT scan. 4 marks. So you have to mention slices, voxels, X-rays and receiver moving 360-degree around the patient, multiple scans, and a 3D image or information about every slice is separately obtained. But can you do the box thing? Here's the question. He says this is the box. Background radiation is 26. What will the values of A, B, C, and D? Find out the values of A, B, C, and D. This is A, this is B, this is C, this is D. So first of all, you have to subtract something and then you have to divide with something. What will be the final answer?
From A, B, C, D, it will be 7, 11, 2, 6.
That makes sense. 7, 11.
2 and 6.
2 and 6. So this kind of questions normally come for CT scan. Okay, one is that describe the principle of CT scan, and second is these